Students, here we will cover the topic FIR filter design using window technique. For this, we have to know about HD omega, that is known as desired frequency response, and another thing is HDN, that is known as desired sampled response. HD omega is represented by HD omega, that is desired frequency response, is represented by n is equal to 0 to infinite HDN e की power minus j omega n. If we'll take the Fourier transform, inverse Fourier transform, that is IFT of HD omega, will get the HDN, that is sampled desired sample response, that is given by 1 upon 2 pi minus infinite to infinite HD sometimes it is it will be not omega e की power j omega. Here we are using omega, so we'll write here HD omega e की power j omega n into d omega. These two equations is very important, so we have to learn these equations. And what do you mean by window technique? By using window technique, we have from question we have the desired frequency response. Then by taking the inverse Fourier transform, we'll convert the finite, that is sampled frequency response. After multiplying the window technique, we can fix the length of the filter. For example, rectangular first and very simple window is rectangular window. It is defined by WRN, amplitude is 1 for the value of n, that is goes from 0, 1, 2 up to length of the filter, that is m minus 1. Other it will be otherwise. So first step, we have to take the it is given in the question, we have to take the inverse Fourier transform of HD omega, will get HDN. After that, we multiply HDN into WRN, that is given window function. Then what will get finally the sample responses, not the desired sample. It will get the sample responses by multiplying the window function. So let's proceed to the numerical. Example, we'll take given HD omega equal to e की power minus j omega tau for omega is less than equal to omega c 0 otherwise. Sometimes here it is the angular frequency and this is the cutoff frequency. Also here it is given omega c is equal to 1 radian per second, and also length of the filter is L is equal to 7. It is given in the filter. So length is defined by capital M. So sometimes we'll get the question e की power minus 3j omega, 2j omega, but here tau is the unknown quantity. How will know the omega c is 1 radian per second? So limit will be like minus infinity to infinity, it goes by symmetry property minus 1 to plus 1. But the if tau is given, then we'll solve. Tau is equal to, we know this one, m minus 1 by 2 if the length of the m is equal to 7. So the value of tau is 7 minus 1 by 2 equal to 6 by 2 equal to 3. So what is the value of tau is 3. Then we can say step 1, we can say desired HD omega is defined by, put the value of tau in this equation minus 3j omega for omega. Put the value of omega c. It lies between -1 to +1. It lies between -1 to +1, 0 otherwise. Let's proceed. What we'll do next? We'll take the Fourier transform. Inverse Fourier transform of HD omega given by this equation. What we'll get? Desired simple response. From the next page, let's mark it step 2. We'll write by taking inverse Fourier transform by using the formula HDN equal to 1 upon 2 pi. What will be the value of minus infinite limits will goes -1 to +1 by putting the value of HD omega, that is e की power -3j omega. Right, corrected here also, that is e की power, because here is e की power -3j omega. 3 is the value of tau. 3 omega into e की power j omega n into d omega. So -1 to +1 is the range of cutoff frequency, that is WC mentioned in the question. So by solve the integration 1 upon 2 pi -1 to 1, we can write it e की power j omega n minus 3 into d omega. By integrating this 1 upon 2 pi e की power j omega n minus 3 divided by j n minus 3, limit goes -1 to +1. Expanding this 1 upon 2 pi e की power j n minus 3 by putting the value of omega -1 to +1 minus e की power minus j n minus 3 divided by j n minus 3. So here we will use the formula of Euler's identity. What it will say, or it is also known as by trigonometric identity. It is defined by sin theta equal to e की power j theta minus e की power minus j theta upon 2j. So e की power j n minus 3 represent the theta, and 2 will goes here. So make in this sense HDN equal to 1 upon 2, 2 goes inside. So here we have pi n minus 3 inside. By making this form e की power j n minus 3 minus e की power minus j n minus 3 divided by 2j. We can write this whole term as sin theta, 1 upon pi n minus 3 sin theta. But what is the value of theta? In place of, write it here, n minus 3. So this is the desired sample response, but when n goes equal to 3, because length of the filter is n is equal to 0 to n minus 1, that is 0 to 6. When we will put in this equation n equal to 3, it will goes 0 by 0 form. So this solution is valid for n not equal to 3. This is also we use for all the values 0 to 6 except n equal to 3. To overcome this problem, that is 0 by 0 form, we'll apply L'Hospital rule. L'Hospital rule. What it says? It says differentiation of numerator and differentiation of denominator. So HDN equal to d by dn sin n minus 3 upon pi is the constant, d by dn n minus 3. What will we get? We'll get cos n minus 3. It will goes only pi. If we'll put n equal to 3, what will get? HD, the value of HD 3, that is n minus 3, 3 minus 3 0, cos 0 equal to 1, will get the solution 1 upon pi. Okay, now come to the third step number 3. We'll use the rectangular window function. Using rectangular window, it is defined by WRN equal to, it is always 1 for n equal to 0 to 6. How we'll get 6? Because the length of the filter is m, that is 7, 0 to m minus 1. So 7 minus 1, 0 to 6. It is 0 otherwise. Now we have the formula Hn is defined by Hdn multiplied with Wrn, but we can see Wrn value is 1. So इसमें 1 की multiply करेंगे, we'll have the same value. So we'll make the table as here we'll put value of n, here value of Hdn that is equal to, क्योंकि Hdn में WR की multiply करेंगे that will goes 1, तो Hdn become equal to Hn. Now put the value of n, where we'll put in this equation, we'll put the value of n, and when put n equal to 3, we have already solution. So put in this equation, when n equal to 0, what 1 upon, पहले फॉर्मूला लिख लीजिए, 1 upon n की प्लेस पर 0, n minus 3 sin 0 minus 3, तो sin minus 3 upon minus 3 pi. After solving this, we'll get the value 0.015. When n equal to 1, to put the value pi 1 minus 3 sin 1 minus 3 sin minus 2 pi. After solving this, we'll get 0.145. When n equal to 2, we'll get, I am writing here directly, put the value of n, so we'll get, after solving, 268, n equal to 3, we have already find out 1 upon pi, that is the value of 318. N equal to 4, 0.268. When we'll put n equal to 5, 0.145. N equal to 6, 0.0149. So we'll get the value of Hn. So here we can say the coefficients of filter is at the value of 0 to 7. That is the answer.